Okay, this tutorial is going to help you answer and understand any exam question that deals with knowledge on the factors that affect the amount of sunlight reflected from the Earth's surface. So if you look at the checklist, we're basically talking about the area of knowledge which comes under the global heat budget. Now, the first thing you need to do, or you can do, is have a little look at a model answer, which is available on the revision site. And this is the sort of question that you're looking to answer. Describe and explain why the Earth's surface absorbs only 49% of the solar energy received at the edge of the atmosphere. You should refer to conditions both in the Earth's atmosphere and at the Earth's surface. Now, you may get a diagram with it, and the diagram might look something like this. If you look in the class textbook on page 15, you'll see a similar diagram. The only difference is the percentages are different. And my recommendation is to go with the one in the textbook, but it doesn't actually matter because it's not about the percentages. That's not the key point. It's about the processes in different parts of the atmosphere and on the surface that help you understand this. Okay, so let's get started. The first thing to understand, and the first thing you would say in any answer, is that at the Earth's atmosphere, it receives 100% of what we call insolation. That's incoming solar radiation. And the first thing to bear in mind is as energy travels across the solar system to our planet, it comes in the sense of light rays. Now, these are what we call shortwave radiation. There is no heat here, that's why it's freezing in space. And the heat only happens when these shortwave rays interact with our atmosphere and generate heat. And this is part of the process you're explaining. So the first part of your answer is to tell us that 100% of the radiation arrives as shortwave radiation from the sun. Now, what happens to it? Well, if we go back to the diagram, we can see that some of it's reflected and some of it's absorbed. And your answer is really about explaining the amounts that are reflected and the amounts that are absorbed. Okay? Now, if we just deal with the reflected, in total, we are looking at 17 plus 8 plus 6. So that adds up to 31% in this case. It does vary depending on which particular diagram you're using. But if we go with the idea that 31% is reflected, whether it's by the surface, by gases and dust, or by the clouds, we need to think why. And this brings in your first major part of an exam, and the second major part, I should say. The reflection is done by a thing called the albedo of the Earth, also known as the albedo effect. Now, if we just drill a little bit deeper into what this idea of the albedo effect is. Well, the first thing is to talk about the reflectivity of different surfaces. And if we think about our diagram and how much is being reflected by clouds, just jumping back to the diagram, we had 17% reflected by clouds. Clouds are made up of water vapor, and therefore they have a quite high level of reflectivity. They're light, most of them in color, and therefore light hitting these clouds, a lot of it's being reflected straight back into space. Approximately 17% according to the diagram. Also, traveling as light travels through this atmosphere, it's going to interact with a lot of gases like hydrogen, helium, and all the other gases in the atmosphere, as well as dust particles that are floating up here. And as this shortwave radiation, or light if you want to call it that, hits these particles, they're just bouncing back off into space. Now, according to the diagram, about 8% is happening because of that. The final part of reflection that you want to bring into your answer is what's going on the Earth's surface. And there's actually an awful lot you can say here, and there's a lot of marks you can pick up in an exam answer. Because whilst the surface is only reflecting 6%, the amount that's reflected from different parts of the surface does vary. Because different objects or different surfaces have different reflectivity. So if we think of a mirror, for example, as having a high level of reflectivity, reflecting 100% of light, let's think about certain surfaces. If light hits the Amazon rainforest, which we can see in this photograph, well, it's got a very dark surface because it's made up of leaf and tree canopy. And therefore, it's going to reflect quite a low amount, and actually, rather than reflect, these dark surfaces will absorb quite a lot, Yes, there will be some reflection, but there's going to be an awful lot of absorption of that shortwave radiation. In contrast, if the light falls upon Greenland, which I've got a map here of, well, in that case, because Greenland is made up of a lot of ice, ice has a very high albedo, and just like a mirror, will reflect a large amount of light and will absorb very little of it. So light falling upon areas like the ice of the Arctic or Greenland or any glaciers is going to reflect large amounts and absorb very little. Light falling on darker areas like the Amazon rainforest, or as a matter of fact, oceans. Oceans have a very low level of reflectivity. They absorb a lot of shortwave radiation. Then, depending on the surface, different amounts of light will be absorbed or reflected. So you really want to put that into your answer. You want to talk about the albedo effect and the different reflectivity absorptions of different surfaces, mentioning specific surfaces like Greenland and the ice sheet there reflecting huge amounts, absorbing very little, and the Amazon rainforest because it's a dark canopy of leaves, absorbing a lot and reflecting very little. Okay, so now what we've done is our answer has had 4 steps to it. We've talked about 100% coming as shortwave radiation, known as insolation, incoming solar radiation. We've talked about the 17% that's reflected by clouds. We've talked about the 8% that's reflected by gases and dust. And we've got some explanation about the 6%, a lot of detailed explanation to do with the different surfaces. As a matter of fact, there's 2 points there because you've talked about 2 different types of surfaces. So right now your answer has got about 5 points worth of marks. That brings us to the second part of the answer, which is absorption. Now, we can see here that approximately 23%, according to this diagram, although some diagrams will show you 19% like the textbook, is absorbed by clouds and dust in the atmosphere. So the clouds just soak it up and it never gets to us. It's just soaked up and absorbed by the cloud. So the cloud has a temperature in itself, or the gas particles absorb it in the atmosphere. Eventually that stuff that's absorbed will then re-radiate back to space. It's not going to just stay there forever. It's going to then leak back out. And that's a point worth making in your answer. The other part that's absorbed is what's happening on the actual surface itself. Because if we think of this image that I'm about to bring up here of a coffee cup, if you think about the coffee being the planet, and that coffee's got a lot of heat in it, so the planet is now absorbing. Now, of all of the heat, and in this case, if we go back to our diagram, 46% is absorbed by our planet. So we put that to our coffee cup. 46% that came from the sun has made it to the coffee cup and is absorbed. What happens to it? Well, it's re-radiated. Now, 6% of it is, like the steam here, is going to just go straight back into space. Not this time as shortwave radiation, however, as long-wave radiation. In this case, it's going to be heat. Remember, shortwave radiation was light, long-wave radiation is heat. What about the other 94% that leaks up? Well, it does leak up also, but it then gets absorbed by clouds, by water vapor, by carbon dioxide and other gases as heat. And just like the stuff that's going straight back into space, the 6%, that 94% will also eventually leak back up into space. So there's 2 points you've brought in now. There are some other areas you can also bring into your answer. You can talk about the amount that actually comes into the planet from incoming solar radiation does vary. So certain areas of the planet will receive more than others. So, for example, if I bring up this little picture here of the axis tilt, because in our winter time, for example, the northern hemisphere is tilted away from the sun, we're at a greater angle. Therefore, what you find is, because we're at a greater angle from the sun, there's more reflection off the surface happening than during our summertime when the sun's more directly overhead. So the amount of incoming solar radiation varies throughout the year in areas in the northern and southern hemisphere far away from the equator, and that's to do with the axis tilt. Other things that can influence the amount that we get. So, for example, in cities, because cities are made up of lots of glass and light surfaces, there's a huge amount of reflection in an urban area, a bit like the glaciers and ice sheets of Greenland. Whereas in a rural area, because there's lots of vegetation, dark surfaced vegetation, there's going to be a lot more absorption. So there's a difference in the amount that is absorbed and reflected, whether you're in an urban or a rural environment. Those 2 points about the angle changing throughout the year, affecting the amount different areas of the planet gets, as well as urban and rural, can give you another additional 2 points.